Welcome back to this channel. Today we are going to continue with 3.2 periodicity. So in this subtopic, we are going to discuss the atomic and ionic radius, ionization energy, electronegativity, physical property, which including the boiling point and melting point, and also the acid-base character of oxide, which across period and also going down the group generally. However, in today or in this video, we only focus on the variation in atomic and ionic radii. Let's look at what is the objective for this video. Okay, this is the learning objective for this video, which are related with the radii. Radii is the plural for radius, at where in the Bahasa we will known radius as jejari. Okay, so beside from using the words radii, radius, sometimes you can see we are using the term size. Okay, the size of the atom or the size of the ion. Okay, learning objective A and also D are the one that you roughly get the idea in your lecture. Okay, describe the variation means that you have to know that across the period the size is getting smaller. In the first row of the transition element, the size does not change much. While going down the group, the size is getting larger or bigger. Okay, and then what is the meaning of isoelectronic? Okay, it means they are going to have similar number of electron, or because of the species consists of similar number of electron, hence they will going to have same electron configuration. Okay, so in this video we are going to look in detail because we are going to analyze. Means that why across the period the size getting smaller, why the size does not change much for the transition element, and also according going down the group why the size getting bigger. And then next we are going to compare the atomic radius with the ionic radius, and then we also will compare the radius for the isoelectronic species. Next, we are going to learn about the ionic radius across the period 2 and 3. Okay, so basically we just need to know either period 2 or period 3 because the trend are similar. Means the element, if the element in period 2 become ions, so how the changes of the radius. Okay, let's go in detail. What is the meaning of radius? So as you already know that we say that radius in Bahasa is jejari. So if in mathematics, normally we will learn about jejari in the topic of circle. So means that in a circle, so what is the definition for the radius? So it is from the center until the circumference. Okay, so in chemistry context, the center is actually the nucleus, while the circumference will be considered as the valence electron. Okay, so just now I already introduced you the terms of radii, radius, and also size. And then if you still remember, in the previous part, we have the word atomic radii, and also you can see the word ionic radii. Okay, so both atomic radii and ionic radii, they are different. Okay, so for atomic radii means that the size of an atom. Okay, however, ionic radii means that the size for an ion. So later we will go through why the atom and also ion will have different size. okay, because of gaining or losing the electron. Okay, because from the definition here we have the idea nucleus, the distance between nucleus and the valence electron is the definition of the radius. So if the electron is getting more or getting less, means that the number of valence electron will be getting more or less. So definitely the radius of the ion will be different from the radius of the atom. Okay, however, if you look at the definition, we are going to define that it is half of the distance between nucleus of identical atoms. Okay, so the nucleus here actually is the meaning of nucleus. If we only have one nucleus, then we read as nucleus, okay, singular. So but if more than one nucleus, we will going to read it as nuclei, okay. So this one is mean more, two or more than two nucleus, then we are going to read it as nuclei, okay, of identical atoms. So as we already know that valence electron is very not just valence electron, the size of the electron is very small. So it is very difficult for us to look at the, to identify the valence electron. Furthermore, from chapter 2, we have the idea that electron will be always moving, and also we are very difficult to predict the position and also their velocity or momentum at the same time. Okay, so that's why difficult for us to detect the valence electron. Then we will going to measure the distance between nucleus with another nucleus, but with the condition these two nucleus must be identical atoms, okay, and then we divide by 2, so will become the radius, which is the distance between the nucleus to the valence electron. Okay, so next I'm going to show you one diagram. Okay, this diagram is about the size of the atomic radius. Okay, so if you look at this one here, all these are generally arranged in order, is like similar in the periodic table. So we know that across the period from left to the right, we will notice the size is getting smaller. Okay, while when going down the group, the size is getting bigger. Okay, these are the idea that you obtain from the lecture. So now only, next slide only we will going to focus on the idea that maybe not touched during your lecture time. Okay, now before we go in details to do the analyzing, why the trend across the period is getting smaller and why going down the group the size will getting bigger, we have to understand what are the factors that will affecting the variation of the atomic radius. Okay, generally there are two factors which will determine the atomic radius. The first one is effective nuclear charge. Okay, so effective nuclear charge with nuclear charge are different. Okay, what is the meaning of nuclear charge? Basically, nuclear charge will be considered charge of nucleus, while effective nuclear charge is the charge that felt by outermost electron or valence electron. So normally I will use the analogy as, for example, you may have 10 teacher with you, but among these 10 teacher, maybe only 2 of them you are afraid with. Okay, so that's one is called the 2 teachers we will consider as effective nuclear charge. But how many teachers you have? You may have 10 teachers. That is the nuclear charge. Okay, so effective nuclear charge increase, the size will getting smaller. Okay, this is the summary or the conclusion. Okay, you will going to get this idea. The higher or the greater the effective nuclear charge, the smaller the size. Okay, in next slide, we are going to look at how we are going to determine the effective nuclear charge. Okay, second factor that will going to study is shielding effect. So another term for the shielding effect is screening effect. Okay, so from the word shielding, basically we get the idea block. Okay, menghalang. Okay, apa yang menghalang? So again, we will also going to look at the details in next slide. So we generally get the idea first. When the number of shell occupied by electron is increasing, means that the shielding effect is greater. If the shielding effect is greater, then the size of the atom also will be greater. Okay, so these two inner orbital, okay, we consider these are the screening effect or the shielding effect. Okay, now we are going to look at each factor more details. So first, we are going to discuss about effective nuclear charge, at where the symbol can be like ZEFF. Okay, EFF is effective, Z is referred to proton number. Okay, or number of proton like mentioned in here, while the S here is represent shielding constant. So I think shielding constant is a bit abstract for us. So basically it is considered of number of inner shell electron, or we can just simplify as number of inner electron. Okay, so what is the meaning of inner? So inner basically is from the word in. Okay, means that electron yang di shell yang lebih dalam. Okay, so again we look at the definition for effective nuclear charge, which state that it is the net positive charge that can be felt by the electrons. Okay, so again, the larger the effective nuclear charge, means that the valence electron experience stronger nuclear attraction, and means that the valence electron will be pulled closer to the nucleus, and then means that the radius will become smaller. Okay, so we take the sodium as the example. So sodium have 11 electrons. So if we write the electron configuration, will be from 1s2 up to 3s1. So based on this electron configuration, N1 filled with electron, N2 filled with electron, N3 also filled with electron. So N3 will be considered the outermost shell, while N1 and N2 will be considered of inner shell. So how many electrons in N equal to 1 and N equal to 2? If we look at here, total up the blue color one here, 1s2, 2s2, and 2p6 means that we have 10 electrons in the inner shell. So that's why we are going to use 11 minus 10, which equal to positive 1. This is the effective nuclear charge for sodium. Okay, one new term here, core electron also can be considered as inner electron in this case. So again, just want to let you know, the nuclear charge for the sodium is positive 11. Okay, which means that generally the nucleus attraction towards electron, like just now I mentioned, you may have 11 teachers. Okay, but effective nuclear charge is positive 1. Okay, only one teacher sahaja yang you takut dengan. Okay, means that that is the net charge felt by the valence electron. Okay, just roughly for example lah. Okay, ada 11 teacher bagi kamu kerja, tapi you hanya akan hantar seorang teachers punya kerja sahaja. So maksudnya teachers itu ada like the charge power on you. Okay, so this is what I mean by you have to alert with the term nuclear charge and also effective nuclear charge. Okay. Now we're still in chapter 3.2, and then we're still on the topic of across the period by explain using the effective nuclear charge. So now we look at across the period, the radius is getting smaller. Okay, this is the idea that you get in the early of the video. And then why the radius become smaller? Because the effective nuclear charge is increased. Therefore, the size is getting smaller. So these are the example of the element in period 3. Okay, so now here, just now we already used the example of sodium. So in this slide, we are focused on magnesium until the silicon, at where we are across the period. So as we know, the element arranged in order of increasing proton number, okay, across the period. So if sodium have 11 proton, means that magnesium has 12, aluminium 13, and silicon 14. So when you write the electron configuration, based on what you learned in chapter 2, for magnesium we will up to 3s2, while for aluminium up to 3p1 and silicon up to 3p2. So from here, all these 3 atoms consist 3 shells occupied with electron, which is n equal to 1, n equal to 2, and n equal to 3. So again, n equal to 3 are considered as the outermost shell, while 1 and 2 will be considered as inner shell. Okay, so again, across the period 3 from left to the right, okay, from left to the right, what is going to happen? The proton number increase. Okay, and then because of the electron is added to the same shell, so shielding effect is constant. Okay, so we will continue shielding effect in the next slide. So just keep in mind that, okay, means that the number of shell occupied by electron is remain still 3. Okay, all these 3 atoms consist of 3 shells occupied by electron. So we consider shielding effect is constant. Okay, so because of this, effective nuclear charge will also increase. Because of the proton number increase, next, and the effective nuclear charge also will be increased due to the constant shielding effect. Okay, so once the effective nuclear charge is increased, so means that the valence electron, okay, so here please add on valence electron. So valence electron will be pulled inwards. So inwards here means near to nucleus. So when the valence electron is near to nucleus, based on what we understand about the definition of radius, which is the distance between the nucleus with the valence electron, so will become smaller. Okay, because of this, then in conclusion that we will going to say that the size is getting smaller or decrease in atomic radius. Okay, so now we are going to prove that. But is it true that effective nuclear charge is increased? Okay, this is why we say here, when the proton number increase, but the number of inner electron constant. So 12 minus 10 we get positive 2, 13 minus 10 we get positive 3, and 14 minus 10 we get positive 4. So all this showing us that across the period, when the proton number increase, at the same time the shielding effect remain constant, will cause the effective nuclear charge increase, and then the valence electron will pull closer to the nucleus and make the size become smaller.